Hello friends, welcome back to the discussion. Now we will be going ahead with the discovery of electron, which was previously discussed in the first lecture while discussing the statement given by John Dalton. In that he said atom is a indivisible particle, but in later 20th century there are many other allegations with regard to atom, and it was proven that atom is not the smallest particle. It is further divisible into three subatomic particles, namely electron, proton and neutron. Previously we just discussed about the features of all these three particles. Now we will be going into the discovery of these particles. And now in this lecture we will be covering the discharge tube experiment, in which both electrons and protons were discovered. Okay, now let's get continued with this. So discovery of electron was made by J. Thomson, and he discovered the subatomic particle called as electron in his discharge tube experiment. This is a very simple discharge tube, or it is called as cathode ray discharge tube. Here this is made up of glass, and these are two thin metal plates. One acting as cathode, other acting as anode. We know that cathode is a negative electrode towards which cations are attracted, and anode is a positive electrode towards which negative ions, that is anions, are attracted. So cathode is a negatively charged electrode, whereas anode is a positively charged electrode. Now in this apparatus, this is the space for vacuum pump. What? Vacuum pump? Why do we need this? Yes, we need this because gases, when charged up, need low pressure and high voltage to conduct electricity. Okay, high voltage is understandable, but why low pressure? What will low pressure do? So low pressure creates gap between the atoms, through which the conductivity of gases is increased. There is a high electric discharge of nearly 10,000 volts in this partially evacuated cathode ray tube. In this, there is a high voltage of 10,000 volts, nearly electric discharge from cathode to anode. In this process, he noticed that there were some particles moving. How did he notice? This was a simple cathode discharge tube, but after that, while he got a doubt that there are some particles moving, then he got to the other discharge tube. Here he coated one of the end with zinc sulfide. Zinc sulfide has a property of fluorescence. Fluorescence means when it is hit by highly charged particle, it shows a mark. And now fluorescence is, in general, it is self-luminous. Now you can see here, this is the cathode and this is the anode. Here it is again the vacuum pump, which is used for the evacuation of partial gases. Or in actual, you can see the anode here is perforated. Perforated? Yes, perforated means there are tiny holes in the anode. Because Thomson got a doubt that there are some particles moving from cathode to anode. Yes, there were particles moving from cathode to anode, and these particles, there was a gap made between the anode, and these particles were let to pass through it. After passing through these holes, the particles hit the zinc sulfide screen, where it was recorded by the little marks. See, this is the zinc sulfide screen, and here from this we got to know that yes, there are some particles traveling from the cathode to the anode. That is, this signifies that particles are traveling towards positive charge. Yes, particles traveling towards positive charge. When will the particles travel towards positive charge? When they themselves are oppositely charged, right? Yes. This is one of the proof that cathode rays are negatively charged, and those cathode rays are further called as electrons. Now, these rays aren't visible, but their behavior can be observed. Yes, because I said due to benefit of doubt. What benefit of doubt means? A doubt in which can prove that yes, he is going to be right. In that, due to benefit of doubt, he placed a zinc screen. Actually, the particles weren't visible, but the zinc screen made Thomson observe the behavior of the particles. After this experiment, he went on to another one. The same experiment carried in 3 different apparatus, and in this he placed electric field and also magnetic field. Why that? Yes, he placed electric field and magnetic field. He placed electric field and magnetic field to observe the deviations of negatively charged particle. Negatively charged particles are, in general, after applying electric field, they are deviated towards left. At magnetic field, they are deviated towards right. Without any field, they are moving straight. These were the properties which made him believe that electron carries negative charge. Characteristics of cathode rays doesn't vary with varying material of charge or gas in the, what is this? In the cathode ray discharge tube. Yes, because generally every gas or every subatomic particle is generally categorized by its E/M ratio, or it is called as specific charge. That is charge to mass ratio. Charge to mass ratio of electron is 1.78820. Yes, charge to mass ratio of electron is 1.758820, and now that was this charge to mass ratio of electron. Do you see any mass varying for electron? No. So how could the characteristics of electron change? That is the reason why, let it be any gas will just release an electron, which any gas will just release an electron which has same mass. That is the reason why characteristics of cathode rays doesn't vary with the material of charge or gas in the cathode ray tube. This is an overall view of discharge tube experiment for the discovery of cathode rays. Now let us go with Let us go with Goldstein. What did he discover? He discovered a proton. Yes, the proton was also discovered in discharge tube experiment. But this time the practice was in reverse manner, that is, they used perforated cathode. The similar experiment was performed. Similar experiment was performed by reducing the pressure, by lowering the pressure and supplying highest voltage possible, and the same result was obtained. But there were particles of opposite charge found. Now you see E by M ratio of proton. In this discharge tube experiment of proton, actually Goldstein found not proton but positively charged ions. All positively charged ions show the same result. All positively charged ions show the same result. Yes? Yes. That is the reason why canal rays or anode rays or protons have what they have. They have different characteristics when gas is changed in the container. The gas inside, if it is hydrogen, then only after losing an electron it can become H plus, that is a proton. Otherwise it will be some other element and it will be weighing more. As the weight of the element increases, the specific charge increases. Hence, canal rays have different characteristics. And now we will be going towards the discovery of neutron. Neutron was discovered by Chadwick in nuclear reaction. The reaction is beryllium 59 was hit by alpha particle, that is He24, which gave rise to carbon 612 and what is this reaction? I think beryllium is 4, right? Yes. Beryllium is 4. Atomic number of beryllium is 4. Atomic number of boron is 5. Here, beryllium was a metal hit by alpha particle, abiding to the principle of conservation of energy, you see, or conservation of mass. You see here, 9 was the weight of beryllium and 4 was the weight of helium. In the product side, you can see 12 as carbon and 1 as neutron. Hence, this reaction is justified. In this reaction, actually, Chadwick was astonished that where did 1 unit of mass vanish? How can a unit of mass vanish? No, a unit of mass will never vanish because every reaction need to abide by the theory of conservation of energy and conservation of mass. So that is the reason why they discovered the other particle called as neutron. Now let's conclude this session. These are the discoveries of three various experiments in which 3 subatomic particles were discovered. Please, the notes for this will be provided on the Telegram channel. The Telegram channel is also the same thing, that is stepping into chemistry. Please don't forget to subscribe the channel for further updates.